The angular position of an object is where the object is located in the circular path relative to a reference position. For example, let's just say that our reference position for the circle is the very top here. So if I just create kind of like a set of axes that's like our x and our y, if we say at the very top here that our theta is equal to 0, that's going to be our reference position. What that means is that any position that we have on here is going to be how the angle has changed relative to that reference position. So for example, if we have an object right here exactly in between, we can say that our angle here is 45 degrees. So it has an angular position of 45 degrees from our reference position. We can also say that this is going to be pi over 4. The reason why is typically our angular position will be given to us in radians as opposed to degrees, but you should be able to handle both radians and degrees when you are trying to find the angular position. What happens is as we keep moving around the circle, the angular position will change. Eventually we will reach our initial position again, and we'll be back at 0. Then if we were to keep going, we'd just have our 45 degrees pi over 4. Angular displacement is a little bit different because the angular displacement can carry over. So while theta is our angular position, delta theta is going to be our angular displacement. If you are in your first turn, the angular displacement and the angular position are virtually identical. What changes is when you have subsequent turns. So for example, if I were to go around the circle once, my angular position would be 0 again. My angular displacement would now be 2 pi radians. If I were to go around again, my angular position would still be 0, but my angular displacement would now be 4 pi radians. The angular displacement does add up, while the angular position remains just between 0 and 2 pi radians or 0 and 360 degrees. So you have to kind of keep that in mind when you're looking at your angular displacement versus your angular position. More times than not, I'm going to ask you for your angular displacement, but there will be a few occasions where I will ask you, where is this object located in the circular path? Because there are some interesting applications to the angular position. So you have to be able to handle both angular position and angular displacement in this unit.